because then the people have to start, okay, I have all this knowledge now, let me earn a lot more money now than I earned in a dream project, and I'm coming up with some new geospatial company that uses this data. Okay, we talked about this briefly. This is the product that's mainly to be generated. I mean, look on the floor, you have, I think these are half meter by half meter tiles on the floor. So just imagine you cover the entire Philippines with 4 of these tiles being one tile, so a little bit bigger tiles, 1 by 1 square meter tiles. So, and then in the middle of these tiles you put one number. One number on every tile. And the tiles are 4 times as big, so they're 1 by 1 meter. All of the Philippines. And that number in that tile should say how high is the terrain at that time, plus minus 20 centimeters. That's the goal. And with that data, you can do a lot of things. Namely, you can do a lot of interesting things in terms of computing where the water will flow when it rains, or where the water will come in when a storm surge is coming. And that's really the goal behind the project. We've seen that slide before. So let's look at it a little closer. So we have a plane. Then we have some stuff on the ground. Stuff on the ground, you know, some tree. Well, your trees have a bit more clothing on. And there can be other stuff like birds, as a bird. So then this plane shoots down the laser very often. We heard up to 500,000 times per second. Actually, that's when 2 lasers shoot at 250,000 times per second. So I think the highest repetition rate right now is 400,000. But, so these pulses, it's like a shock. This pulse is very short. It's like 4 nanoseconds long, so it goes. And much faster than this. And don't worry, the bird is not going to get harmed. Because you can think of it like, it's like a laugh laser. Yeah? It's not like the James Bond kind of laser, because that would chop that bird right in half. It's like it's gently touching the bird. And just sort of sensing where are you, and then it continues on. That's what happens. This light beam is coming down. And then this light beam interacts with things on the ground or in the air. And these interactions, this is what, for the most part, people call LiDAR. These are the LiDAR points or the LiDAR returns. This one is usually the most important one. Unless you like to study the flight patterns of birds, maybe then this one is important. But people usually don't use LiDAR. So this one is really important. You don't always get this. Sometimes the tree is too thick, so the laser cannot hit the ground. Or if that's not like a little Tweety bird, if that's like a big eagle, yeah, so then the laser may stop right on the bird, because the bird is completely blocking the light. So when that laser comes down, depending on how high you fly, it's not the laser that you know from the PowerPoint presentation that's like a little needle. It becomes bigger as it goes down. So when it hits the ground, it's maybe 20 centimeters, 25, 30, 40 centimeters, depending on how you fly. So yeah, you need a pretty big eagle to block the laser. Maybe a little dragon or something. This is actually not the real plane, I found out. But you know, whenever I give this talk somewhere else, like in Europe or in Canada, they wouldn't know the difference. Anyway, this is Joyda. This is another thing. When I came first here January 13. 13, yeah. When I came January 2013, Dream was still pretty new. They just got the first data. And Joyda, to me, you know, she was just a little girl, a little intimidated by all this technology. And when I come back 2 years later, she's like a kick-ass LiDAR scientist, you know? So that's quite a transformation. I was able to see myself. That is really something cool. Yeah, I just got these pictures off the website, and here you see I think this is the Secretary Montejo. He was christening that plane on November 22nd, 2011. I think this is a really cool project. I think you can be really happy that your government is running this project. I mean, in the news, you know, you hear a lot of these things, you know, like corruption. I opened the newspaper, I see pork barrel, must be a big thing right now, right? Yeah, there's many bad things. But this one, I think, they got it right this time, you know? So, you can also start to think about the good decisions the government takes. All right, here, the PowerPoint doesn't like the Philippines. No, I opened that in LibreOffice, it's an open source version, and it messed up the graphics. But you've seen that graphic before. There was Dream, the first stage. So these are a bit older slides where it was only a third of the Philippines. So that's a lot of data. And we look at that a bit later. So here you see the Papaga River Basin. That's one of these colorful things that you saw on the earlier slide. Just to illustrate you how much data there is. So before Chris talked about the flight patterns. And here you see, initially they had two planes, and one was one they colored green and one they colored pink. And this is the pattern you see is 5 by 5 kilometers. So one sortie of the plane is this. So it's a 5 kilometer by 30, 35, 40. So every time the plane goes, it comes back with LiDAR data for one of these areas. I think it's like a 4-hour survey, maybe. You know, come, take off, come back. And it goes back and forth maybe 10 times, plus minus. And for every square kilometer, for every square meter, it tries to get 2 or 3 shots for every square meter. 2 shots on average. Now, every shot can give more than 1 point. You know, you hit trees, you hit buildings along the way down, you hit birds, plastic bags that fly, swarms of honeybees. I mean, you know, whatever could give you a LiDAR return. So that means you get about this many million points per square kilometer. And if you look at the amount of square kilometers you want to process, this is a lot of points. So many points, I mean, it's hard to even think about how big this number is. This is a lot of raw data, and then when you process this, typically you make duplicates of the data as you do so. And yeah, so why am I here? Well, when I heard about this project, about the size of it, and about how it's implemented here in a country that didn't have a single LiDAR scanner before, it's kind of funny. I mean, the US, they still haven't decided on a national LiDAR survey, and they have hundreds of companies with hundreds of LiDAR systems. And the Philippines didn't have any, and now they have 3, and they're already, you know, like one-fourth of the way of a national LiDAR survey, and you know, on track to complete the entire country soon. So that's quite an impressive feat. I'm a computer scientist, like Marie said before. I'm not a LiDAR person originally, somehow I have become one. In computer science, we just solve problems, or we just can come up with solutions without knowing the problem yet. So for my postdoc at UC Berkeley, I said I'm going to find a solution for triangulating a lot of points. Here, a lot of points, maybe 1 billion. And I'm going to triangulate them in a lot of triangles. And I'm going to do this with a very small memory buffer on like a regular laptop. That was my idea. And I got some money from the National Science Foundation to do that. And afterwards I realized which problem I had solved. Only afterwards, when I met the LiDAR people. Because having the big triangles wasn't very useful. So instead of storing the triangles, I piped it directly into another small process, and that rastered the triangles and created a big DEM. At that time, for me, LiDAR was just a source of a lot of points to experiment with my algorithm. And that LiDAR data is actually from the North Carolina flood mapping project, one of the first statewide projects in the US. That was after Hurricane Floyd in 1999, which was quite devastating there. So I presented this algorithm at this GIS conference, which was my first GIS conference, and shortly thereafter, ASCII invited me to their headquarters to make me give this talk and afterwards offer me a job. So I said, oh, there's a lot of interest in processing these LiDAR points, and I really like working with these maps because suddenly I could tell my grandma what I was doing. You know, like before, like he's doing this computer stuff. Like, no, he makes maps. Oh, maps, yeah, everybody knows maps. You know, that's easy. So the first time I got my half billion points, I got them as a gigantic zipped ASCII file that looked like this. Now this representation, ASCII, is a good representation for 10,000 points, 100,000 points, or maybe 1,000,000 points. But if you have 100 million points, it becomes very inefficient. Because this is good for humans to read. That's how we write our numbers. The computer doesn't write the numbers like that. So he has to translate them back into the way the computer, that's into a binary number. And that takes a lot of time. And then if you go from one ASCII format, you do some processing, you use to another ASCII format, then you use your beautiful computer for nothing else but a translator from a human format to a machine format to a human format for no good reason. I still use these formats sometimes when I need to find an error, because then I need to manually look through and do the computation myself. But I only do it then. Other than that, I use binary formats. And the American Society for Photogrammetry and Remote Sensing created this LAS format. You know, they're just laser LAS. They did that early. It was actually a bunch of people that own software, and they said, well, let's find a way so we can share the data from one software to the other. And we are quite happy in the LiDAR community that this has been done, because there's another similar community, the multi-beam echo sounder community. They have not done this. So when you work with HiPAC, you are a slave to HiPAC. And if you work with Caris, you can't leave their system because their formats, you can't go from one to the other, and it's really bad for the user. So the LAS format was a real blessing, and it's simple and it works. It looks like this. And you need to understand all of this. I'll ask you a question about it tomorrow morning, okay? No, it's actually, it looks horrible. This is just a header. Every file has a small header. And in this header, there's a number of information in there which are quite easy to understand once you spend some time on it, which will not be in this very moment. And then for every point, you have a record. For example, this is the most common record. Most of the data from the DREAM project is in this format. The point data format 1. The difference to 0 is that it has a GPS timestamp. So every point has a stamp when it was taken in time. What else does a point have? Well, the point has coordinates, X, Y, Z. Then the point has an intensity. And how strong was the reflection? Yeah? So when you hit a white piece of paper that's lying on the ground, this is a big number. If there is a little black bird flying, you know, with maybe, or like a little fluffy chicken or something like this, it's maybe not so high. And if you hit a tar roof, like made from some black material, this number can be very low. Or like a black street, like a tar street. And when it's wet, it's also low. Then the return number and the number of returns of the pulse. I told you, one pulse can have multiple returns. And these returns are numbered. First return, second return, third return. If we have 3 returns. Or first return of 1 return. Then this was just 1. That's quite often do. And a few other little details that we will look in later. And that's these files. There's nothing more to it. There's a header. It says, you know, some parameters. And then maybe 20 million times this thing repeated. That's the file. And yeah. So when I got the first files, I like, what's that? it's binary, you can't read it. You need to use the software. And there was I needed to get these points so I could run my experiments, and I couldn't find any software to read it, so I just wrote my own. After all, I was a computer scientist. That's what we do. And then I wrote a little API and some little tools. These tools you should all know by the end of the week. And I put it on my webpage. And because I was writing a bunch of tools to work on LAS files, I just named the folder LAStools. And then I zipped it. So it was LAStools.zip. And that's exactly the thing you're copying on right now, except we now 7 years later, and I spent several years of my life making this a really good software. At the time, it was just, I thought, oh yeah, I needed that for my own research. It was a side product. Oh, by the way, there is a website called LAStools.com. This is not me, okay? It confuses a lot of people. LAStools.com is not me. Somebody registered that like 8 years ago or 7 years ago, and it says to be updated soon, and it has been to be updated soon for the last 7 years. It's a dead project, and I asked the guy, can I have your webpage? And he said, maybe I do it someday, so I want to keep it for now, but I don't think anything will happen there. So, LAStools.com is not me. RapidLasso.com or LAStools.org, that's me. So, lots of more developments. There's a user group. Anybody who sent me an email, we maybe want to use LAStools in our project. Can you send me a quote or something? I all invited you to that user group. Maybe it was your secretary that wrote me the email then. Maybe she's a part of the user group now. I don't know. I'm not sure I'm online here. I don't think we allowed Facebook at the university during. We have to wait until 6 p.m. But LAStools is active also on the social media because I like to mix fun and work. Maybe it's because I'm mostly doing nothing else but LAStools at this point, so I like to have some fun while I'm doing it. But there's always something funny going on LAStools Facebook page. But I also make announcements there, like serious announcements. The Twitter account is more for announcement, and then I have a LinkedIn group that's sometimes funny but mostly serious. But for working and for answering questions and for learning about LAStools, the Google groups on LAStools is the most important one, and I hope I can organize them being online eventually, then I can go over that, but we have a number of days to do that. This is how LAStools looks like. LAStools has a GUI. I wrote that GUI myself, and I'm not particularly proud of it. It's not a beautiful GUI. It's a bit awkward. But it has some ways to it that make it quite unique because the GUI is also teaching you. It teaches you how to use LAStools efficiently by typing the commands. And once you become advanced users, what you will do, you will write a number of sequence of tools in one batch file, and then you will run these batch files instead of individual. And what these GUIs do, they teach you the commands you need for the batch files, and that makes them good. So what's the state right now? Has everybody copied that LAStools.zip file? I mean, that was a bad way of answering that question. Who doesn't have the LAStools.zip file? Everybody has it? Yes. Wow. That's efficiency, yeah. Okay, how about, has anybody unzipped it already? Yes? Alright. So let's have a look at what's in this folder. So if you unzip it, the zip file has only one folder. And in order to do anything now, you will need to unzip that folder. For example, for me, the folder was somewhere here on the desktop. It looked like this. Sometimes you have a different symbol when you use WinZip, and then I double click. For you, maybe another program will open, and what I then did I just basically, in my case, I went to the C drive, so I just clicked on it, and then I drag and dropped it. Yeah. I did like this. I drag and dropped it onto the C drive. Now I did it already, so I'm not going to do it again. But that's all it takes to install LASTools. After you did that, you should see exactly, you have a folder. In this case, I put it on the C drive. I like it on the C drive because for the exercises, or on the D drive or on the E drive, it makes the passes that we will see very short. It can be helpful for the exercises. Maybe you don't have access to the C drive, maybe you have a D drive. It doesn't. You can also put it somewhere else. I prefer to put it here because it makes all the passes very short. Now what do you have then here? The most important folder is this one. The bin folder. The bin folder, that means short for binary, that's where all the actual executables are. And if we have a quick look into that folder, you have all these little programs. And they should look like this. If they don't look like this, we have a problem. If this doesn't look like a little gray thing that's like this, but is a box, then you haven't uncompressed it yet. I really dislike how Windows makes you look into a compressed folder and it looks just like a normal folder, because it's not a normal folder. After the only way you can tell it is these usually have a square box with nothing in it if it's still compressed. It needs to have this little symbol. If you see that little symbol, then you're good to go. So here are all the little programs. And there are quite a lot of them, and as LASTools evolves, more and more are coming. For every program, there's a little file called README. That's a text file that explains in great detail what awesome things you can do with this particular program. Now, I have plans to rename this to Do Not Read Me, because I want to employ reverse psychology to make the people actually read it. Okay, before we actually started, let's look what else we have in the LASTools directory. There is a folder called Data that has some small example data in it. These are used in some of the README files. This is just very small data. LASTools is partly open source. So the other folders mostly have to do with, there's a source code. So if you know how to program, or if you have a friend who knows how to program, you can potentially write particular small tasks yourself that are not implemented yet. By using these libraries, and here a number of tools are also open source. Here you can see the source code. One of the most important tools is, like the Swiss Army knife of LiDAR processing, is last to last. You have one last file and you want to go to another last file that's a little bit modified. That's open source. You can actually look in how is Morten doing this, you know, what's happening behind the scenes. What's also open source, and I'll talk about this later, is LASZIP. LASZIP is a compressor. We talked about LiDAR is very big. So especially if you transfer files from one place to the other, or from a server or you need to burn it to a disk and give it to somebody, or then it's sometimes beneficial to compress it. And then you get an LAZ file. More on that later. There are toolboxes for QGIS. QGIS 1.8, 2.0, 2.2, and 2.4. You don't need it anymore. It's already integrated. So if you load QGIS 2.4, you can directly enable it without following the complicated instructions here. There's a README file, how to do that exactly. And if you like ArcGIS, that's the same thing. It's just going to be a little less efficient because everything else already is a little less efficient. QGIS rocks. And it's free. You can copy it as many times on as many workstations as you want. The license will not expire. The license server will always be responding. And then there's something called example batch scripts. And there is what I said before. LAStools, my GUIs, will teach you, sort of a little bit, how to type directly in the command line, and we'll do that later also, which is in the beginning a bit intimidating for people. The command line. The command line is, I don't even know how to start it anymore, because Windows really hides the command line from you. They're trying to, I think if I go, I run here, Task Manager, and now I go, and I go here, and I say run new task, and I say command. That's the command line. This scary black window is behind everything. Also, you don't see it anymore. It's really where everything's running. And, here. That's how to look at the directory. A lot of people don't like working with this. I think it looks really difficult. I think the reason it looks so difficult is when you watch an action movie, and I know you guys, you really like the Hollywood movies, like The Bourne Identity or, like Mission Impossible or something. There's always this guy, in every of these movies is this guy who is at the computer and he like hacks into the enemy station and opens the door. Or like hacks into the Pentagon and gets a secret file. And this guy usually uses a command line. But the guy also is socially awkward. He doesn't look like he showers very often and he only eats junk food and, But it's not like that. You can use the command line and have good body hygiene and eat lots of vegetables. Alright. Oh, so I actually wanted to do something. So where are my LAStools? Here are my LAStools. So now I would like you to actually start a LAStools. And I told you all the programs are in the bin directory. So I would like you to go in the bin directory and then look through the list until you find the LAStool, and that should be towards the end, called, and that's a very, very simple tool that doesn't really do much processing. It's more like for inspecting. And that's really helpful to learn in the beginning. It's called LASView. How do you start a LAStools? Well, you can just double click it. And then, and now I realize I have a little bit of a problem because my screen is very small. I didn't realize I would have such a small screen computer. I hope that in the break, I think we have a break in 15 minutes, I will be able to change computers to get a higher resolution screen. I hope it's not the projector, because then we need to change projectors, which will also be possible. Anyways, so I have to improvise a little bit. because I don't see the whole thing. You should have bigger screens. You should see the whole window. And these are the GUIs. The GUI of LAStools all look the same. On the left side, it's always the same controls. On the I cannot change the I cannot, oh, I can move it, but